And then I've just started recording so that we can put this webinar up on our website once we are all set. So let's dive right in. I want to first say thank you to our co-op partners on the Phoenix and Scottsdale area co-ops. We're working directly with two organizations that have helped us out in the past as well to support the co-ops, and those are Arizona Interfaith Power and Light, which is a nonprofit organization that works with all kinds of faith-based institutions in support of working on climate change issues. And so solar and clean energy is a part of their mission. And then with Physicians for Social Responsibility in the Arizona chapter, and I see that Barbara Warren has joined us this evening, and she's the chapter director. Really want to thank her. She was instrumental in helping our Tucson co-op really go super well last summer. We had almost 170 households signed up for that group. And Physicians for Social Responsibility does a lot of really important work to promote safe energy like solar and support rooftop solar. So thanks to Barbara. So we're going to talk a lot about this tonight, but just wanted to put it up front. So if you want to join one of our solar co-ops, these are the websites that you can go. So if you live in Scottsdale or generally the East Valley, you can sign up for the Scottsdale Solar Co-op, which is solarunitedneighbors.org/Scottsdale. Or, excuse me, if you live in Phoenix or the West Valley, generally, you can sign up at the same website, but /PHX. And so the co-ops are called the Scottsdale Solar Co-op and the Phoenix Solar Co-op, but really these are valley-wide initiatives, and you would just sign up for one or the other depending on where you live. And if you're not really sure which camp you fit into, you can just sign up for one and we'll put you in the correct place. So a little bit of background on Solar United Neighbors. We're a national nonprofit organization that is working to build a new energy system with rooftop solar at the cornerstone. Our mission is to help people go solar, help people join together in their communities around solar and clean energy issues, and fight for energy rights, which is our advocacy and policy work. So we're trying to help real people put real solar panels on real roofs and do it in a group process that helps to lower the costs and spread knowledge around so that people are informed consumers. But we also want to create community around solar as going through a shared process together, and pay attention to some of the policies that are out there that could either erode the ability for more people to go solar or help more people go solar and support those policies. And so we're kind of doing both in different ways. And we always like to talk about equity as a part of our work, because we do think it is important, and we have some initiatives going on organization-wide to support greater equity, especially in energy as a part of our work. And first and foremost, that comes with recognizing that we do live in an unequal society, unfortunately, and that home ownership is a prerequisite for putting solar on your roof, and not everyone has really had that opportunity historically, and those divides are still here and with us. And so we're running pilot programs in places like Washington, D.C., Indianapolis, and we're talking to some cities here about how can we support communities of color going solar and having ownership of solar and working on those issues. And so if you're interested in those types of initiatives, definitely reach out to us. We got started as an organization in 2007, and it says it wasn't easy. And this was, born out of a really kind of grassroots way, and really started with these kids here. So the kid in the green shirt is, his name is Walter. And one day, like many of us 15 years ago, saw the film An Inconvenient Truth and was really jazzed up about wanting to solve climate change, came home and lobbied his mom and said, we need to go solar on our house, and how can we do that? And so she started looking into how that could be possible, and started to figure out that it wasn't going to be easy, that there was a lot to learn about how solar worked and whether it was right for them. Was it worth spending all of that money? And then they started having issues trying to actually find a contractor to come to their neighborhood in DC and do the install. And so they thought, well, if we're having these problems and we need to go solar, more people need to go solar as a society to save money on our electric bills and save the environment, there's got to be a lot of other people out there that are thinking about this too and are going to have the exact same questions that we have. And so Walter got his friend Diego, and they started going door to door in the neighborhood and asking people if like, hey, have you ever thought about going solar? We're going to start a cooperative around trying to do this together. And so that's how the Mount Pleasant Solar Cooperative started. That was their neighborhood. And they ended up getting just around 50 people to join, and had kind of a long process, but they were able to get some companies then interested and help them through navigating everything. And then they started getting calls from across the city and across the country, like, hey, this is a really cool model. How can we replicate this and scale it up and bring it to more places around the country? And so now we have programs in 12 states and Washington, D.C., including the Arizona program, which was started just 2 years ago. So far nationally, we've run 280 of these solar co-op groups. We've helped over 5,400 households go solar through those co-ops, installed 43 megawatts of rooftop solar, $112 million worth of solar and related equipment and labor has been invested in our co-op groups. And then over the lifetime of those systems, people are going to save $189 million in energy costs. And then those systems are going to offset 1.3 billion pounds of CO2 over their lifetime, which is around 25 years. So we're going to go through solar technology, how the co-ops work, and then solar economics in the next 3 phases. So we're going to start with technology. So this is a basic setup for how solar works. So if you've ever thought, hey, I want to go solar, but like, how does it actually work? I know I see it in my neighborhood, and I, curious about it, but what does it really, what does it really mean? And so we're going to get into that, but this is the basic setup. So you're going to have solar panels that will be attached to your roof. And then the sunlight will turn into electricity from the cells, the silicon cells that are in the panels. And that electricity is generated as direct current, or DC, from your solar panels. And in order for your home to use the electricity, it needs to be alternating current, or AC. And so the energy has to go through something called an inverter in order to make that switch. So there's going to be an inverter as a part of your system. And then from there, it gets connected to your electric panel, where your home will draw from the energy that's being produced. And so if the sun is shining in your home during the day, your solar panels are producing power, and anything that's being produced right there, that if you have your AC running or if you have your lights on, those are being powered by your solar panels. Anything you're not using, so if you're not home during the day, or if you're just not using a lot of energy, it goes back through your utility meter, where it's counted for how many units you send back. And those show up as credits on your bill. And so it depends what utility you have and what rate plan you're on how those credits get applied. But that is how your bill ends up being lowered, is both that you're using less energy from the utility because you're consuming the energy you create right on site, and you're sending a little bit extra back and those go right on the lines, and wherever your neighbors are using energy, they're going to be consuming it and paying the utility for it. And so the utility needs to pay you for the privilege of you sending them the energy. We're going to talk in a couple of different terms here. So just to level set, we're going to be talking about kilowatts and kilowatt hours. And so systems are measured in kilowatts as a capacity, so as a size factor. Panels are typically something like 300 to 350 watts per panel. And so those can add up to being, and there's 1,000 watts in a kilowatt. And so those systems can add up to, the average system size we see is something like 7 kilowatts. Most homeowners are going to install somewhere between 2 and 12. In Arizona, we see averages around 7. Depends on your electricity usage. And then the electricity production of those panels is measured in kilowatt hours. So how many kilowatts are produced coming out of the system. And that's also how you're charged by energy from your utility, which is in kilowatt hours. So you've probably seen that figure on a utility bill before. So we're going to run through the system components of going solar. So what is all the equipment that's included in a solar purchase? And the main one obviously is the solar panels. So solar panels are built in the way you see on the screen, where the solar cells in the middle are really kind of captured by and protected by the rest of the panel setup. Panels are also called modules, so those phrases are interchangeable. And then once you string them all together, it's known as an array. Solar panels come with a couple different types of warranties. So one is a manufacturer's warranty, which basically says that the panel is not going to break, is going to withstand hail and different types of different types of weather. They are built to last, and those warranties are typically 25 years, and panels will last up to 30 years or longer. The other warranty is a power production warranty. So the panels will be warranted. A common one is that they'll be producing around 80% of the power they would produce in year 1, they would produce in year 25. So those are a couple of different types, and those warranties can vary a little bit based on the type of panel that you're buying, but generally you're looking at a 25-year warranty structure around solar panels. The next piece of equipment is the inverter. So again, this is the thing that changes the electricity from DC to AC so that your home can use it. And there's basically 2 different types of inverters that are on the market today. One is the central string inverter that you see on the left and in the middle. The one in the middle is more commonly used these days, I would say. But generally, this means that your entire array is strung together and connected to this single inverter. And because of that, it can, one panel being off can fluctuate the whole system. And so the installers generally now use something called a DC optimizer to make sure that if one panel is shaded or if it's kind of being wonky, that it's not going to mess up your whole system. The other type of inverter is called a micro inverter. And this inverts the energy at the panel level. So you're gonna have a bunch of kind of smaller inverters that are inverting the energy right on site, right at the panel. And so those have warranties that are the same as the panels generally because they're built into the panel system. Those can be good for a couple of reasons. If you have panels that are going to be shaded part of the day, or if you just generally want to, have a deeper view into your energy production, you're going to have a panel by panel level view of that production, versus the central string inverter is really just looking at the entire system. And generally, the string inverters have warranties that are maybe 10 to 12 years long, because after that time, you'll probably need to replace it at some point throughout the lifetime of the solar panels, which are more like 25 years. And so the microinverters can cost a little bit more upfront. And then how does your system connect? So simple connection usually into your electrical panel. The solar company, one of the first things they'll do is ask to see your electric panel and make sure that it can handle the solar installation. And some older homes do require electrical upgrades and at an additional fee. So how do solar panels attach to roofs? There's this is called racking, and there's a few different ways that panels are generally racked, and pretty much all roof types have a racking solution for you to be able to go solar. So the most common one is the one that you see here, where there's basically a flashing that is there's a roof penetration that anchors the flashing into the roof, and the flashing is tucked underneath the shingles so that there's no water that will flow into the penetration. And then from there, there are beams that are connected to those points, and the panels are attached to the beams. And so that's a pretty standard way that solar is attached to an asphalt shingle roof. If you have a flat roof, there's options to ballast the panels or weigh them down, or to use something called a pitch pocket, which is if let's say you have a flat roof, but it faces north, you might want to tip your panels up so that the panels actually face south, so that you can maximize your energy use. And we'll kind of get into the different angles here in a minute. Parapet wall buildings, you can use beams and attach them that way, or seam metal roofs like we see in northern Arizona or some other places. You can clamp solar on to a lot of those types of roofs. If you have a Spanish tile roof, on a newer one that's not the real clay but is more like the concrete tiles, installers will work with that, and they will do a version of the flashing racking solution that you see on the left that you would use for an asphalt shingle roof. Some folks in more rural areas opt to do a ground mounted system, which means that you can install more solar and angle it in the exact optimal way. Ground mounted systems come with additional costs like trenching, and because you have to build a structure that accommodates the solar, and it's not just being attached to an existing structure. But that is an option for some folks. And then we've been talking about this a little bit, but what is a good roof for solar? So best is if the roof is facing south or facing west. And that's because you're going to generate the most amount of electricity from your panels, and that will help with your return on investment. The east is okay, north is not recommended. And the reason why west and not east is partly because when the time that most of us are using energy, like right now, is an expensive time of day on most of the rate plans that we're on, or all of them that solar customers are offered in the Phoenix area. And so if you're able to capture that sunlight as the sun's going down to the west and use it to power things in your house, then you're going to save a lot of money that way. You want to make sure that there's not a lot of shade on your roof, that there's not a big tree in the way that's going to make it harder for your panels to produce power. And then you need enough space to mount the panels in unobstructed space. So it's really hard to, the system needs to be efficient, and you can't just put 4 different panels on 4 different surfaces. You really need to have enough space on 1 or 2 surfaces in order to maximize the output and make it economical for the installer. So we're going to talk about batteries as well, because this just comes up a lot, and folks have a lot of questions. It's a new technology, and the costs are coming down, and the technology is improving, and sort of what does it all mean? So the first question that relates to batteries is just what happens when the power goes out and you have solar. So when the grid goes down, your solar is going to shut off, there's a mechanism in the inverter to shut it down. And that's for safety, so that you're not sending extra electricity back to the utility lines while the workers are solving whatever issue has happened in your area. If you do want energy and power during an outage, you need to have a backup battery in place. And that can be a closed system that your battery will be recharged by the solar, and then your home will take from the battery bank during an outage. So, folks that in Texas, for example, during their recent blackouts, or the blackouts that have been happening in California, the folks that have done okay during those times, at least electricity wise, are folks that also had battery backup with their solar. So that is the sort of the main draw of battery storage, is that it's used for backup power during outages. There's one other kind of main use that people are using batteries for right now, which is to help to offset peak energy use. So both APS and SRP have electricity charges that are based on peak hours of the day. So typically, like in the summertime, those are the late afternoon and early evening hours. Power's really expensive. And both of those in the summertime go until 8 p.m. at night, and sort of for half of the year. And so when the sun goes down at 7 o'clock, and you're no longer producing power from your solar that you can use, you could draw from that battery instead of starting to draw expensive power from the utility. And you can also draw from it, overnight, and then just recharge it earlier in the day when electricity is otherwise cheap from the utility to buy. And so that daily cycling can help to offset some costs, but in our modeling, it generally is not going to pay for itself yet. And so, the batteries are still pricey enough where the main value draw is for backup power. In the future, utilities may allow you to sell them some energy from your batteries, and they could pay you a decent amount from them during certain events. So let's say that hottest day of the year, and the grid is really stressed out and doesn't, instead of turning on a expensive and dirty gas power plant, they could come to, 30,000 battery customers and say, hey, would you give us 20% of your stored solar power and release it? And that way we can have enough energy on our system. And so those things are still, the rules of the road are still being written, and we're part of some of those conversations. Something similar to that did happen in California last year with battery storage customers. So it's something kind of interesting in the future that may be possible with battery. And so Tesla Powerwalls are one that you may have heard of. LG Chem is another one. There's a few different types on the market. And if you want to know more about storage, we have a guide on our website at that link right there. Do want to mention electric vehicles as well. So, and then we'll get into the solar co-op model. There's a lot of crossover. Maybe some folks that are here right now already drive an electric vehicle. And so if you go solar, you'll have the opportunity to, plug that vehicle in and charge it with your solar instead of charging it from the grid and, paying the utility more. In order to kind of do this in a more economic and speedy way, a lot of folks opt at home to install a level 2 electric vehicle charger. And I'll explain what that means in a minute, but we do get pricing on that in our process. And so that's something you could opt to do at the same time that you go solar. So when you lease or buy an electric vehicle, you get what's called a level 1 charger that comes with the vehicle. And it's just a regular plug, essentially, that goes into a 120 volt normal outlet in your house. But the charging speed is really slow. So it's like 5 miles of charge per hour. And a lot of cars to fully charge, takes about 20 hours in order to charge enough. So level 2 charging is about 4 times faster than that. And so you can charge at 20 miles an hour, but you do need a 240 volt outlet in order to install, to basically plug the level 2 charger into. And so if you have an existing outlet in your garage, great. Then you just need to buy the equipment to plug it into that. Otherwise, most solar companies can also install the 240 volt outlet for you that the equipment would plug into. So something to think about if you are interested in kind of preparing yourself to have an EV, if that's your next car, or if you have one already and you want to just kind of knock it all out at once. I just have the DC fast charger info on here for reference. DC fast chargers are the kind of commercial, really fast chargers that are out there that needs a special outlet, and they're super expensive, but they are the ones that are kind of coming more online, and I think eventually will kind of replace our gas stations. This is an example of the level 2 charger. So 10 to 30 miles an hour, a lot of them around 20, kind of depends on the car, depends on the charger. And there's a variety of units out there. All right, so let's get into how the Solar United Neighbors, solar co-ops work. And again, feel free to ask any questions in the chat as we go along. So, why go solar with the co-op? Where we can get competitive group pricing from local companies in our process. So we get dozens of households in the metro area to sign up for the group. And then we'll kind of run through the step-by-step, but with that group buying power, we can get pretty competitive bids from installation companies. You get support from Solar United Neighbors throughout the process. So we have, we're available by email and by phone. If you have questions, if you're having an issue with the installer, we can help you work that out. So we are vendor neutral experts that can navigate you through the process. And then we strive to also connect you with fellow solar enthusiasts. And so folks that, may want to investigate a new technology together, or have different, similar questions. We are often connecting folks that, went solar in the same co-op. And this actually happened this week, where someone got a battery after their initial install, and they had some questions. And so I connected them with someone that had that same experience, but then had the expertise and some more experience with the battery. So we can kind of connect folks that way. And then just trying to, become a greater part of the solar movement. We're trying to engage solar owners across Arizona to install more solar, do more co-ops, and win on some of the policies that we're working on. This is the TikTok on the solar process. So steps 1 through 3 are really about learning about the co-op, signing up as soon as you're interested, and then helping to grow the group. So the bigger the co-ops get, the more buying power that we have when we go to step 4, which is to issue a competitive request for proposal, or RFP, on behalf of the co-op to local solar companies. We ask a ton of questions like, what are your prices? What are the panels you offer? What are the warranties you offer? What is your staffing size and capacity to handle a group like this? What are your diversity practices? There's a whole host of things that are responded to through the process. And then we review the bids, make sure that the equipment is something that's worth installing, or flag if there are any issues with that. We check and make sure they're licensed, and then we call through references, customer references that are provided to us from the companies to kind of just get anecdotal information about them. And then once we have those bids, we convene a group of members of the co-op who will review the bids with our support and ultimately pick one company for the co-op to install based on that bid. And so for this particular sort of the co-ops that we're running now, we have a Phoenix group and then we have a Scottsdale group. And so those groups will make different decisions with different group members. They might pick the same company or they might pick two different companies, and companies will be invited to bid on both groups. And so I would expect that there's a lot of crossover in the bids when we get to that point. And then there'll be a sign-up deadline. So the sign-up deadline for this is the end of June. So we have 3 months to grow the groups, and the installer does get picked about halfway through. So once the installer is chosen, we'll continue to sign folks up. And the folks that have signed up early, so probably a lot of the folks that are here tonight, you'll be the first ones that the installer will call, because we asked them to call through the folks that were excited initially and signed up, sort of call through folks from when they signed up earliest through the latest. And then you'll be offered a proposal by the installer that's based on the group pricing that came through in their bid. And at that point, you can decide whether you want to sign a contract or not. It is up to you. Joining the co-op is free, and there's no obligation to go solar with the company. It's your decision. And so at that point, you can sit with the contract and decide if you want to sign it and ask us any questions. And then if you do decide to install, then you will get on their schedule. They'll work with you to get the necessary permits and the utility approvals and to install the system. And then we have been trying to do celebrations. Obviously, it's been hard over the last year to do like this type of celebrations we used to do, which is like invite everyone to somebody's house. But we have been, doing some things on Zoom, and hopefully in the next few months we can see each other in person again soon. The other thing that I'll mention is, the co-op is free to join. We do get, competitive pricing through the process, but what's in it for us? So like, what's our deal in all of this? And that's for every signed contract, the installation company pays us a $600 fee. And that's pretty below market for that type of reference fee, and just helps us as a nonprofit to do this type of education, to launch our next co-op groups, and to continue the type of work that we're doing. So we asked the installer to basically build that in to their group pricing. So hopefully soon we can delete this slide, but since we're still in this, we have moved all of our stuff online. Solar can be purchased and installed with little to no contact. So installation companies will, they can do a virtual visit. They can come to your home and walk around it, do something socially distanced to look at your roof, look at your electrical box, and and really just everything's outside, and so they can install pretty much no problem. And installers were allowed to operate kind of throughout this whole process. And you'll be able to see what there's each company is saying about the pandemic in their bid responses. So just a reminder, who picks the installer? It's co-op members. So Solar United Neighbors, we're here to help you make an informed decision, but it's really up to the group members and the committee of members that raise their hand and say they want to be a part of that process. So when you're signing up for the co-op, you can indicate whether that's something you would like to do. And then we look at all types of criteria. So price, equipment quality, warranties, experience. Are they local or are they a national company? That sort of thing. And that's how folks ultimately make a decision. All right, so move on to solar economics, and we'll dive deep into some numbers here. You may have heard this, but solar is just increasingly affordable. So costs have kind of plateaued over the last 3 or 4 years, but the prices have really come down over the last 6 or 7 years, and definitely the last 10 years. We, through our co-op process, typically secure something like 15 to 20% below market for the average price. So solar is priced typically by the watt, and that includes not only the panels and the inverters, but also labor and most of the rest of, it's a turnkey system for the price that you get. And so if you divide all of that cost by the watt, you'll get this dollar figure. And part of this is because of the way that the cost of solar works today. So the equipment costs are, have fallen and have kind of stayed steady, but then the components of, soft costs, which are marketing to find customers. So paying door knockers, paying salespeople, paying for advertising, all of that costs money. And, often solar companies are paying $1,000 or $2,000 per signed contract just in marketing fees to find people. And so if we can bring installers a group of, educated, qualified folks, because we also will look at your roof and make sure that you can go solar, then that streamlines and lowers their overall costs, and they can pass those savings on to the group. So I want to talk about incentives and then rate structures. So what is and the cost of solar. So just sort of the dollars and cents here. There is a federal tax credit for solar that is going to go down in a couple of years. So this year and next year are pretty good times to go solar based on the federal tax credit. So of an average size system, a 7 kilowatt system at an average Arizona price of $2.75 a watt, you're looking at somewhere around $19,000 before incentives. But the tax credit allows you to write off 26% of that cost on your federal income taxes. And so then the cost goes down by about $5,000. And that's for this year. Next year, in 2023, it's scheduled to drop to 22% and zero out the year after that. I think the new Biden infrastructure plan would extend the tax credits and make it easier for more people to get them, but obviously that hasn't passed yet. So this is the structure that we're working on today. And then there are some local incentives. So the main one is a 25% state tax credit that's worth up to $1,000. So if you're going back to that last example, the federal 26% knocks off about $5,000, and then the state tax credit knocks off an additional $1,000. There's a couple other ones that don't sort of show up right away. But just so you're aware, there's a property tax exemption for solar. So even if solar would increase your property value, it's not going to increase your tax liability. And then there's a sales tax exemption as well. So you're not going to see sales tax on your proposal. So for APS customers, and this is based on our modeling of the current rates, and based on an average price that is higher than what we would probably see in the co-op, but just to be conservative. So we're looking at two different sizes of systems here. One is a 4 kilowatt system, and one is an 8 kilowatt system. So a smaller and a larger. So 4 kilowatts around $11,000 before incentives, and then double that for the 8 kilowatt system. And then after the tax credits, you're looking at $7,000 to $15,000 out of pocket. We're going to go through the APS rates right after this. But based on our modeling, you're gonna start saving in year one, and then over the lifetime of the system, you would be looking at a net profit of something like $9,000 to $14,000 for the small system, $18,000 to $23,000 for a larger system. But that's if you stayed in your house for 25 years. So if this is your forever home, it could be a good investment. You're going to break even on the system in under these current rates in something like 10 to 12 years. So if you look at the estimated 10-year savings on the small system, you're going to break that 7,000 mark somewhere around year 10, and not quite that for the larger system. So something to keep in mind. When you go solar, if you have APS, you're gonna have a choice of 3 different rate plans. And these may actually be simplified soon, but these are the rate options that are available today to solar customers. And you can kind of break them into 2 categories. So Saver Choice is the plan that most solar customers choose because it's typically the most advantageous economically. Saver Choice Plus and Saver Choice Max are not typically what new solar customers choose, and that's because they include something called a demand charge. And that demand charge is a fixed fee based on the time that you're using the most energy during peak hours. And so anytime you have like a high fixed fee that solar can't directly help you to address, you may be better off choosing a plan that's more, even if the energy costs per unit are a little higher, solar can help you to offset those costs. So APS also has a rate comparison tool on their website that has had some issues in the past, but they claim that it is now working for new solar customers. So it's not something you can use if you're thinking about going solar, but once you've gone solar, you can, you can use it today to know which rate plan you should be on. But once you've gone solar, you're also supposed to be able to use it to see which rate plan you should be on. So this is a breakdown of the 3 different plans. And if you want to dive into this deeper, I encourage you to go to their website, or you can reach out to us. But essentially, the Saver Choice plan is the better one because it doesn't have those demand charges, which is that middle category. The prices per kilowatt hour in the top row are higher, but if you're offsetting by using solar instead, then you're able to sort of save on those charges where you couldn't get around paying a demand fee. All of these plans credit you for extra solar at around 10.5 cents per kilowatt hour. And another reason to go solar today versus waiting a year is that next year, that credit is likely to be 10% lower than it is today. And that's part of the Corporation Commission's solar step down that unfortunately is just the policy we're living under. And so going solar this year will lock in that 10.45 cents rate for your system for the next 10 years. So this is a sample bill that I pulled from a real person who went solar in our co-op last year in Phoenix. And so I can kind of walk you through the Saver Choice plan and how it works with solar. So let's say, these plans, energy is more expensive from 3 p.m. to 8 p.m. Monday through Friday, and that's called on peak. So this person used 175 kilowatt hours on peak at a price of 24 cents per kilowatt hour. And so then that charge is $42.55. Off peak, they use 525 kilowatt hours at around 10 or 11 cents per unit. And so that charge is $57. The grid access charge is another solar charge that utilities have right now, APS has. And so for under this plan, this 7 kilowatt system, they charge you by the size of the system. And so it's 7 kilowatts times 93 cents. And so that charges $6.51. And then there's various fixed charges about environmental fees and taxes. So those add up to around $26. But then this person also exported a bunch of solar back to APS throughout the month. And so they sent them 450 kilowatt hours, and at 10.5 or 10.45 cents per unit, that's a credit of $47.03 on this bill. So without solar, this person would have paid something like $130 for this September bill. And actually they would have paid a lot higher than that, because solar directly helped them to not have as high of usage overall from the utility. But this credit is for the extra solar, and so that directly helped them out. But you'll never get your bill down to lower than this sort of like $31 mark, where you have to pay the fixed charges, the taxes, and then the grid access fee. So even if you got everything else sort of perfect, your bill is never going to go below $30. Okay, so we also have SRP, which is very different rate structures. And so I'll try to go through those quickly. But essentially the rate structures for SRP, so everything at the top is the same, but on our modeling, the SRP rates are just really not that good for solar. So it's going to take you a lot longer to break even. So over 10 years to break even generally for an SRP solar array. And that's for the reasons that I'll go through on their rate plans. They do have a couple of other incentives that APS doesn't have. They have a battery storage incentive that is worth up to $3,600. That is going away at the end of April. So if you want to get a battery with SRP, you have to sign up for that this month. The batteries cost, can cost $12,000. And so that is a good incentive, can take a quarter of the cost away. And then they also have a demand controller rebate, which is something that can help you to manage demand charges. So SRP has 4 different rate plans for solar customers. They all have the time of use pricing, and then they all have a $32 fixed charge every month. So pretty high fixed charge, which is, again, a reason why it's harder to go solar with SRP. 2 of the plans have something called net metering, which we haven't really talked about, but it's essentially just this trading back and forth with the utility of the energy you're sending, the energy you're taking, and then there's a net of that at the end of the month, which if you give them more solar than you took, then you have a negative on your bill, and that can help to reduce your bill. But to get net metering, you have to pay a demand charge. And so that's that high fixed charge that people with APS try to avoid. 2 of the plans don't have net metering, but they don't have a demand charge. And so it's sort of like sort of 2 bad options, but there's one sort of good choice out of the 2 bad options in my opinion. And some people use it differently depending on their situation. So we'll kind of walk through that. But the plans that don't have a demand charge only pay you 2.8 cents for every unit of solar sent to SRP, whereas APS right now pays you about 10.5 cents for extra solar. So that's another reason why the SRP plans are just a lot harder to crack. So this is a breakdown of those plans. I would say that still a lot of people are going with the E-27 plan, even though it has a demand charge. And that's because you get net metering back. And so your solar can be worth 4 to 6 cents depending on the time of year and the time of day. But then you really have to pay attention to your demand. And that means like not stacking your appliance use during peak hours. So peak hours are 2 to 8 in the summer months during the week, and then 5 to 9 a.m. and p.m. in the winter months during the week. And so it's important not to be, running both of your laundry machines while you're have the AC pumping, while you're doing the dishes. You're just going to rack up a really huge fee doing that. So some people just kind of stay away from the demand and will take what they can get from SRP in this 2.8 cents and just try to really self-consume as much as possible. And so a lot of folks, to make SRP's rates work, generally get a slightly smaller system that's not going to cost you a lot. So it's not going to take a long time to pay back, but can just help you to offset your energy use kind of right at the point of use. So this is the sample bill with SRP on that E-27 plan. So, and this is kind of how the net metering system works, is if you used 200 kilowatt hours on peak, but then you generated extra 50, then your net is 150, so it's 200 minus 50. And then so you're charged 4.6 cents for each unit. And so you get to $6.93. Off peak, 500 minus your solar, which was 400, is 100 net. And so at 3.6 cents, that's $3.60. So energy is like dirt cheap from SRP on these plans. But you have a demand charge. So you had 3 kilowatt of demand times $7.89. And so that hits you with $23.65. You have that $32 fixed charge, and then taxes are something like $5. And so then you're looking at like $71. And most of that is not even energy charge related. It's sort of built into these fixed fees. And so and that's something you can't really knock down with solar. So it makes it tough. I'm not saying it's impossible. Lots of people with SRP end up doing solar, but it's something to go in clear-eyed on. All right, so getting away from utility rates, talking about paying for solar. So obviously you can pay for solar just like you pay for most other things. You do have a couple of extra options. So one is just paying cash, obviously. 2 is take out a loan. So, talking to your bank, some credit unions have specific solar types of loans available. Some folks refinance and take out some extra cash to pay for a solar system that way. And especially with low interest rates right now, you may want to consider that. You can also take out what's called a home equity line of credit. If you have equity in your home, you can use that credit to pay for solar, and the interest on that is tax deductible because solar counts in the code as a home improvement. And then installers, most of them have their own in-house or third-party financing options. There are a whole ecosystem, I would say, of sort of solar financing firms that have popped up in the last few years. So there could be some enticing options there. We generally ask that folks watch out for special fees related to that. There's often, it's not uncommon for you to pay like an 18% financing fee, which is kind of like an interest rate buy down fee, because then they might offer you a 1.99% interest rate, but you have to pay this kind of big fee up front. So a lot of different options there typically, but we're happy to talk to folks about other ones too. Leasing was something that took off in Arizona, 6-7 years ago, and was more popular when solar was more expensive and when interest rates were higher. But it's not typically a good option to do today, because unless you just have zero tax burden and you just can't access the financing, but you still want to go solar. And that's because when you go with a leasing product, the company owns the system and they will take the tax credit. And so they're, in theory, they're passing on some of those savings onto you in the price of the lease, but We find that that's not always the case when comparing proposals. Leasing also comes with long-term contracts, like 20-year contracts that will escalate over time. So you're paying this company a monthly fee, that price escalates over time, and you could get in a situation where you're paying more for getting solar than you did before you had solar. And so that's a really bad situation. We don't want people to get into that. And then it can also just make selling your home harder. So if you're, if you enter a 20-year leasing contract and you sold your home in 10 years, the buyer has to take on the rest of the 10-year lease. And if they don't like the terms, they could walk away, or you might have to pay to remove the solar system from your home at that time. And so that would be not fun either, because that would be a cost. So some things to think about there. And then tips on how to save once you get solar and get the most out of it as much as you can. So you want to line up your energy use with solar production. So if you can be using energy while your solar is producing, that's going to really help you. If you limit your energy use during peak hours and not use more than your system's providing you, then you're going to limit the expensive charges from the utility. If you're on a demand rate, limiting and staggering your appliance use during those times. And then just, still conserving energy overall. So, don't assume that because you went solar, you just start using a lot. You're going to pay back your solar faster if you still conserve. And, any extra solar you send back is going to help lower your bill. And then I would say smart thermostats really help with especially all of the time-based rates that we deal with in Arizona. Having a programmable thermostat is really helpful. So it doesn't even necessarily have to be smart. It just has to be smart enough to know, turn the air up a little bit at 3 o'clock. You can turn it back down at 8 o'clock, and that will in itself save you a bunch of money. All right, so we are going to wrap up and take any extra questions here. I'm sorry I bumped up right to the end of the hour, but if you want to sign up for a co-op, we encourage you to do so. It's free, it's no obligation. We'd love to work with you and help you through your solar journey. Scottsdale and East Valley, you can join the Scottsdale group, and Phoenix and West Valley, you can join the Phoenix group. If you want to get involved in our advocacy work, go to the Arizona section of our website, or just when you get to our website, sign up for email alerts, and we will start contacting you to see how you want to get involved and to activate, give you opportunities to raise your voice when it's important to do so. We're trying to pass rules for 100% clean energy at the Arizona Corporation Commission. And then if anybody here works for a solar company and wants to have the opportunity to bid on our groups, you can sign up for RFP alerts at this part of our website. And we'd be happy to chat with you as well if you have more questions. And that is it. So sorry that I went all the way to the hour, but we're happy to take any other questions that folks may have, or feel free to jump off and enjoy the rest of your evening. Vincent, was there anything I should address?